Now this is our microprocessor lab, and today's topic is addition of two 16-bit number. Mind it, not 8-bit, it 16-bit numbers. So first we are going to explain the flowchart, which is most important to do any kind of coding or any kind of operation. So first we will going to start. Then load a 16-bit number at 9000 address. When we are going to load a 16-bit number in 9000 address location, then it will divided into these two portions. First, say 8-bit are going to stored in 9000, and second rest of the 8-bit are going to stored in 9001. Then it is especially for 16-bit. For 8-bit we know that the by default register for 18-bit it will accumulator, okay, and for 16-bit by default register pair is there is not register pair is HL pair. So here in up to this my HL pair is full. Now we are going to add a second data. So we have to free this HL pair. So move the data from HL pair to DE pair. Now HL pair is totally free. Next, load the second data at 9001, which is again split into two divided portion. 8 is 9002, here is 9001, the last data is 9001, and here is 9002 and 9003. Then we are going to add these two. One is HL pair, this is in HL pair and this is in DE pair. Now so HL and DE pair, we are going to add HL and DE pair, and now the resultant stored in the HL pair, and we are going to show this 9001. Again the same logic here also. The first 8-bit are going to represent in 9004, and second and the last 8-bit are going to represent in 9005. Then stop. So now we will go for the lab copy. Here is lab copy. First we have to explain the experiment name and then object, what we are going to do, and next is operators use, and next the flowchart, which I have already told in this portion, already explained it. So this one page, and the second page is the program code and the data sheet and the input and output. So let's take a look for this. Yes. So program code is LHLD, which is the command to load a 16-bit data in 9000 position. Then exchange is by default selected for DE and HL pair, which we are going to operate this operation, move the data from HL pair to DE pair, and next load the second data in 9002, load the second data in 9002, and this is the operation, this is the operand for the 16-bit addition, which is DAD DAD DAD. That means already HL pair is by default register pair is selected, and then DAD D. Okay, so DE and HL pair. D is by default DE, and DAD by default HL pair, and the result is going to store HL pair also, and SHLD stored the data, stored the resultant data at 9004. Here also stored the data at 9004, and HLT, here the stop, and here the operand for the stop is HLT. So here the data, here the total database data sheet, and here the input and output. So 9001, 9002, this total portion is one 16-bit, this total portion is second 16-bit number, and this is our output. this total portion is our output, not the two output we are getting. It's not the fact. Okay, so 9004 and 9005, we will go, we will found our result here. Now we have take a look in our microprocessor kit, 8085 kit. So let's see.